Hello and welcome. Introduction. Now, in part 2 of this video series on the task scheduler, I introduce a framework that generates 3 tasks using the ATmega 328P timers. Now, there are limitations in that particular framework. Now, for example, if we have 10 tasks, so we would require 10 timers. Now, if you have 30 tasks, then we would need 30 timers. Now, that can be a problem because most microcontrollers do not have that many timers. So that's problem number 1. Now, problem number 2 is if we have 3 ATmega 328 timers working, then when more than one interrupt occurs simultaneously, the result can be unpredictable and unreliable patterns of behavior can occur. Now, a better solution is actually to use a scheduler. The question now is, what is a scheduler? Now, a scheduler really is a piece of code or software that calls or invoke functions or tasks at a periodic intervals of time. Now, the scheduler usually is a key component of a real-time operating system or RTOS. Probably I'll make videos on RTOS in the future. Now, the scheduler that I am wanting to present in this video is based on the work of an unknown author and also on the work of Michael J. Pond book, Patterns for Time-Triggered Embedded System. Now, let me show you the scheduler of the unknown author first. Now, here is the scheduler written in AVR C by the unknown author. Now, the PDF version of this code is available in the link in the description. Now, I want to acknowledge that the work that the scheduler that I'm presenting in this video is based on this piece of code here that I'm presenting right now. However, I've made several changes to the original code. Now, as mentioned earlier, there is no indication who the author is, and according to Google, as of January 30th, 2023, editing of classic sites is turned off. You can migrate your classic sites for a smooth transition. If you don't migrate your classic sites will be auto-migrated to new sites, and the original classic site will be deleted. So back to this scheduler, the original scheduler presenting here. Here is the start of the code. I just want to point out to you this original code here uses the ATmega 8 operating at 8 megahertz. Now, the one that I'm presenting to you in this in the video is I use the ATmega 328P operating at 16 megahertz, and because of that, I need to make changes to the calculation used in the scheduler. And also in this original code here that we are looking at, it uses timer 0 to generate the ticks. Now, in the one that I'm presenting I used the timer one of the 8 mega 328p. So that's another major difference. And the other thing that I made is to rearrange the arrangement of the code. Now, this code that we're looking at on the screen right at the moment, for example, the definition of the functions are all defined. All right, so here are the more of the functions being defined. Here is the interrupt service routine, the definition of the task. They are all done before the main function. So what I did is I have moved all the tasks, all the definitions of the functions after the main function. All right, so that's the arrangement that I made to the code, and then there are various other minor changes that I made. So I will make both the original code and my code available in the links in the description, and you can then compare the two. Main function. So here is the main function of the scheduler. So we have something called the init scheduler. Basically, that set up the task lists. Then we have here in this example, add task. Basically, these we add the task to the scheduler. Then we have a function here that will enable the interrupts, and then in the main function we have a endless loop that would dispatch the task. So basically this is the main function of the scheduler. Scheduler key components. All right, so here are the key components of the scheduler. There is first thing, there is a data structure, then there is a initialization function, then there is a single interrupt service routine or single ISR that is used to update the scheduler at regular time intervals. Then there is a task status function, then there is a function for adding task to the scheduler, then there's a function called dispatcher. Basically, the dispatcher function causes tasks to be executed when the task is ready to run. Then there is a function for deleting tasks from the scheduler. Here is the data structure, and the structure here type is double underscore or underscore TCB underscore T, and then within that type these are the members or elements. First there is the task ID, then there is this thing called task of the type task underscore T. Basically this is a pointer to the tasks, this one here, and then there is a delay member, then there is a period member. Basically the period is the interval between the subsequent tasks run. Then there is the status of the task, and this task here, the type is being declared here, so it's a pointer to a void function with no arguments. The initialization function, the purpose of this function is to basically prepare or set the timer to generate regular ticks that is used to drive the scheduler. Another purpose of the initialization function is to set up the task list. Here we are. The this portion here basically prepare the timer, or in this case timer 1. So here we set timer 1 for 1 second duration. Then we have the control register 1A, set it to normal mode, and control register 1B, we set these 2 bits to 1 because we are selecting 1024 pre-scalar, and then the interrupt mask, we set this to 01 hexa. That will enable the timer 1 overflow interrupt, and here we set port D to output mode. And here we have the task list, and we're using the dot operator to access members of the structure. Okay, next is the interrupt service routine, or ISR. Now, in the example being presented right now is that is different from the original scheduler code. I'm using timer 1 for the ISR. So the timer overflow interrupt is used to call the task or the function at a particular time. Basically, this ISR is used to generate the ticks that will drive the scheduler. So the ISR provides timing, and the timer overflow interrupt works in conjunction with the task dispatch task function to execute the tasks. Let's take a look at the details. So here is the ISR timer 1 underscore OVF underscore VECT. Now here we use this value as C2F7 hexa and load it into the timer control register that will set it for a 1 second duration. Here we clear the interrupt flag, clear the interrupt flag, and here basically we check the status, and every time a tick occurs, the delay attribute of each task is decremented. Now the next function is the get task status function. Basically, this function is to get the status of a task with a given ID, and it will return an error if the ID is invalid. And here is the C code for it. It's pretty straightforward. It checks for the status of the ID, and if the ID is invalid, it will return an error. Function for adding task. Now the add task function basically scans the list of tasks, and when it finds a stopped task, it replaces the stopped task with a new task. Basically, the old task will be overwritten by the new task. The new task is set to be now in a runnable state or ready to run state. Now, as mentioned earlier, the function basically adds a new task to the existing task list or task array. Now, this is to ensure that the tasks are called at the correct or required times. Now, the parameters of the add task are such. Basically, you have the add task function, 3 parameters. The first one is the task ID. The second one is the task name. Now, I've chosen to use task 1 as the task name. Now, you don't have to use task 1. You can call it anything else. Then the last and final parameter is the period. Now, this is the interval, all right, between the tasks. And here is the code for it. So here we have the task ID, the name of the task, and the period. and basically this will check the status of the task. So if the task is stopped, it replaces the stop task, all right, with the new task and change the status to runnable state. The dispatcher function. Now this function dispatches tasks when they are ready to run. Here's a flow chart that describes the function of the dispatcher. So you first of all start the dispatcher, determine which task is ready, any task due to run. If yes, then you run that task. If no, you basically end the dispatcher. Here is the code for it. So you have you check for the which task is ready to run here, and then if it's ready, you run it. You reset the delay, and that you change the status to runnable. That means ready to run. And there is the delete task function. It can be necessary to delete tasks from the list of tasks or array. Now to do so, the delete task function can be used as follows. All right, so this is the code for it. So the task is removed from the list, and stop is equivalent to removing a tasks. Now, what follows is basically the 4 tasks that I have that I'm using for the demonstration. So task 1 basically turn on the LED connected to bit 2 of port D, and task 2 basically will turn on the LED connected to bit 3. If not, it will turn it off. And then task 3 will turn bit 4 on, and task 4 will turn bit 5 on. Now, the tasks are basically identical except for the bits that the LED, except for the bits that is being used in the task. All right, to test the code, we require some hardware. And here's the schematic or circuit that we need to build to interface it to the Arduino Uno. So basically, let's take, for example, pin 5. We got this blue LED. The anode part is connected to pin 5. The cathode is connected to a resistor, a 220 ohm resistor, and the other end of the 220 ohm resistor is taken to ground. And this is identical for all the other LEDs. For example, the yellow, green, and red, they're all identical circuits. And over this side is the wiring diagram for this particular schematic here. Code demonstration. Okay, so I've got my board set up here, and I've got the red LED here, the green LED here, the yellow LED, and the blue LED. Now, let us turn to the code, which is uploaded in the Atmel Studio 7. And here, let me just scroll down. Here are the include directives. As usual, here I define the maximum number of tasks for this particular project. So a maximum is 10 tasks. You can increase this if you want to, but 10 is more than adequate. And then here all the defines of the task states here, and then the LEDs that are being used. Red LED is port D bit 2,
I need to correct this. This is supposed to be 2. And then let me just save that first. Then port D bit 3 is the green LED. Port D bit 4 is the yellow LED. And port D bit 5 is the blue LED. And here is the structure or data structure underscore TCB underscore T. We've been through this earlier, so that's this one here. And then I declare all my functions that I'm using. All are void except for get task is the unsigned 8-bit type. Then I declared the tasks that has been used, task 1, task 2, task 3, task 4. And then this is the main function here, as we have discussed earlier. And then following the main task, as I also mentioned earlier, are all the functions. So this is the init scheduler function. This is the add task function, the delete task function, the get task status function, the dispatch task function, and here is the ISR that generate the ticks. And finally, all the 4 tasks that is designed to run on this scheduler. All right, so we've got everything here. Let me just put this here. So if we just scroll back up, all right. Right, so what I'm going to do is I'm going to build the code. All right, so it's building it, and now it says it's 1 succeeded, 0 failed. All right, here. Then what we do is to let me just minimize this. Hopefully you can see the all right, so you can see the board here. So now I go to tools and upload it to the Arduino Uno, upload the code. Right here, the red LED, green LED, yellow, blue LED on. Right, so they are working. So I've got 4 tasks running with this scheduler. Let it run for a little while longer. The blue LED has the longest duration, 6 seconds. Right, and okay, so we got this going, and that's it for this. Oh, wait a minute, let's just go back to the code. All right, okay, let's look at this part here. So I've got task 1 that runs every 1 second. The task 2 runs every 2 seconds, and then task 3 runs every 3 seconds, and task 4 runs every 6 seconds. That's the blue LED. 1 second is the red LED. Task 2 is the green LED, and task 3 is the yellow LED. All right, so if we go down now, scroll down to the ISR, which is responsible for generating the ticks. This value here, that will give us the 1 second timing. Okay, the calculations of this is been shown in the part 1 and part 2. So If you want to know how to calculate this value, please refer those to the previous two videos, that is part 1 and part 2 of this video series. I've shown how this value is being calculated. All right, so one more time, let's look at the operation. Okay. All right. Okay, so that's it for this particular demonstration.
Okay, that's it for this video. I hope you have found the contents useful. Thank you for watching, and I'll see you in the next video. Bye.